Okay, now that we know how to clear fractions, we will learn how to clear decimals. Okay, how about decimals? Is it possible to solve negative 6.3x plus 1.5 equals negative 4.8 without doing anything tricky to the problem? Yeah, we just follow the normal steps, variables on one side, constants on the other. But sometimes decimals can throw people off. These ones aren't bad decimals, but some decimals really do throw people off. So if you'd like to clear the decimals, what can you do? Okay, my rule is I'm going to multiply both sides by 10 or by 100 or by 1,000 or however big of a number I need so that I can clear all the decimals. I look at the decimal with the greatest number of digits after the decimal point and I multiply by 1 with that many zeros. So if there's only one digit to the right of the decimal point, then I'd multiply by 10. But if somebody has 4 digits to the right of the decimal point, I'd multiply by 10,000, or 1 with 4 zeros. So for this problem, there's only one digit to the right of the decimal point, and it happens to occur at each of those numbers. We just look at the place that has the most decimal points. They all just happen to be the same for this problem. So we'd multiply both sides by 10. That'll be enough to get rid of my decimals. So I'd have negative 63x plus 15 equals negative 48. And it's not a lot easier to solve. Like fractions made a big difference, but it is slightly easier, especially for some people that really don't like decimals. Next step, we'll subtract 15 from both sides. So we have negative 63x equals negative 63. Divide by negative 63, so we get x equals 1. So let's try these ones on your own. Pause the video and then come back and see how you did. Okay, for this one, let's look through all these numbers. Okay, the first term has 0.12, so it has 2 digits to the right of the decimal point. Then there's just a 3, he doesn't have any. Then there's a 0.8, he only has 1 digit. Then there's a 0.22, and then there's a 0.6. So the most digits that anybody has to the right of the decimal point is 2. So we can clear decimals by multiplying by 1 with 2 zeros or multiplying by 100. Now we have to make sure that we do it to every term, whether or not it has decimals to clear or not. So when I take 100 times 0.12, that becomes 12x. I can't forget to take 100 times 3. Even though that didn't have any decimals to clear, I can't just pick and choose who I multiply by 100. I have to multiply everybody by 100. So 100 times 3 is 300. 100 times 0.8, it's going to take the decimal point and move it twice, so it would give me 80x, then equals 22x minus 60. Again, it moves the decimal point twice. If I'm multiplying by 100, 100 has 2 zeros, so it moves the decimal point twice. Now I can combine my like terms, so I have negative 68x on the left-hand side plus 300 equals 22x minus 60. So I have cleared my decimals, I've combined like terms. Now I want variables on one side, and then I'll get constants on the other. So I'll subtract 22x from both sides, so I have minus 90x plus 300 equals minus 60. Notice that I'm rewriting the parts of the problem that didn't change. Rewrite the whole problem on every line. Now I subtract 300 on both sides. I get negative 90x equals negative 360. Divide by negative 90 and I get x equals 4, which is a nice, easy answer for a kind of gross problem. All right, next problem. Now this goes back to clearing fractions. If I want to clear fractions, I'm going to find the common denominator of all the fractions in the problem and multiply by that. So the common denominator of 6 and 2 is really 6, but you might have just thought it was 12. And if you multiply by 12, it'd be fine. But if we multiply by 6, we'd multiply both sides by 6, and we have to multiply every term. So don't forget to multiply that 1 by 6. Even though he doesn't have a denominator to be cleared, if you multiply pieces of the problem by 6, every piece of the problem has to get multiplied by 6. So for the first fraction, those 6's will just cancel, and I'll have w minus 4 plus 6 times 1. Then on the right-hand side, 2 goes into 6 3 times, so I'm just left with 3 times 3w minus 1. Okay, next I want to clear my parentheses. The first set of parentheses, that w minus 4, I can just drop those. They're no longer needed. But on the next, I need to distribute that 3 all the way through. So I have w minus 4 plus 6 equals 9w minus 3. Combining like terms gives me w plus 2 equals 9w minus 3. I want all my variables on one side, so I'm going to subtract 9w from both sides. I get minus 8w plus 2 equals minus 3. Subtract 2 and I get, and then divide by negative 8, and I have w equals 5/8. I won't ask you to check that one. You can just look at the answer key and make sure that it's right. But that is how you do that problem. Okay, for these guys, again, we're going to clear decimals on the first one. We're going to clear fractions on the second one. Look at all of the decimals there. The only thing I see is a 1 decimal point on the 0.4 and the 0.6. So multiplying by 2 would be enough. Now I multiply 10 to the 0.4 times y plus 10. That's all one term. And I multiply 10 to the 0.6y. Notice that 10 only multiplied to the 0.4. It does not multiply into the y and the 10 inside. Because if I multiplied it in both places, I'd really be multiplying that term by 100. I have to only choose one. And since 0.4 has the decimal to clear, that's where I multiply the 10 on that term. Now if I distribute the 4 through to the y plus 10, I have 4y plus 40 plus 6y equals 20. Combining like terms and subtracting 40 from both sides would give me 10y equals minus 20. Divide both sides by 10, and I get y equals minus 2. Okay, next problem, look at all my denominators. And luckily, everybody goes into 36. So I multiply both sides by 36. 36 times negative 5/9, well, 9 goes into 36, and 12 goes into 36, so I have 4 times negative 5w and 3 times 11, and then the 36's cancel on the right-hand side, so I'm just left with 23. So that gives me minus 20w plus 33 equals 23. Subtract 33 from both sides. I get minus 20w equals minus 10. Okay, divide by negative 20, and I get w equals 1/2. I can't tell you how many people flip that in their head, and they know it's 1/2 once they see it, but so many people just divide 20 by 10 and get 2. So keep track of what direction you're going and just be careful with that. Okay, last problem. Okay, the most number of decimals I see is 1, so I'm multiplying everybody by 10. On the left-hand side, it's very easy. I just get 2z and minus 7. Now notice I don't take 10 to the inside of those parentheses. Otherwise, I would have really been multiplying that term by 100. Those guys are already multiplied together, so they're just one term. I only take 10 times 0.2. I don't take 10 times z minus 13. Now I distribute the 2, get my variables on one side. Now what happens if all my variables cancel and I'm in the middle of solving an equation? Okay, that means it's either contradiction or identity. Since that's not true, it's a contradiction, and my answer is no solution. That is the end of clearing decimals, and we will have one more section to this lecture that just has a lot more examples of solving different types of equations.